All right, guys, thank you so much for waking up an hour ago and coming to this session. I mean, going to sleep an hour ago and then waking up 10 minutes ago. How many of you feel just awesome this morning? Just like, all right, how many How many not so good? All right, okay, cool. We have a diversity of opinions, and even up here on the stage, we'll keep you guessing. So thank you again for coming. The session today is called Row-Level Security, and we're going to be looking at primarily SQL Server. There have been some wonderful sessions on Oracle VPD with David Booth, but we do have some of that content. But it's likely that because this is such a broad topic that some of your questions won't be covered here. So we're going to make an effort to keep a really big block of time at the end for Q&A. And David's in the field every day in Europe. I think he visited 25 countries last year with tons of field experience. So I find that most customers say, you know, you must know the answer to my problem because you deal with this every day. Sometimes we do, sometimes we don't. We want to keep it fluid, and I'm sure there are tons of DBAs here as well who are going to participate, and so we can help one another in this session. So I'd just like to introduce myself. My name's Anthony Krinsky. I've been with Tableau 4 years now, and it was a real breath of fresh air for me to come to Tableau. I spent 3 years at IBM Cognos. I spent 4 years at Business Objects. I was an unsuccessful entrepreneur. I've been a business consultant and an application developer. So hopefully some of that experience can help me relate to the challenges that you're having. And we're really grateful that you came to Austin and are braving the 27 hotel dance. The music will stop Friday. Hopefully you have a seat. So again, thank you so much. And this is my co-presenter.
Hi there. My name is David Spezia, and I've been with Tableau just about 5 years now. I started in Metro Detroit as a solution architect in the field for about 1.5 years, and then had the chance to really help our EMEA business grow. When I went there the first time, there was only 12 people in all of Europe. Now we're about 400 in Europe now. It's been lots and lots of fun to kind of lead that area. I'm doing OEM pre-sales, channel pre-sales, and now I'm kind of a strategic product architect for the entire EMEA region. So that's fun, right? I get to meet with customers that are having real problems, taking Tableau to massive amounts of scale, including when we have row-level security involved. And it's always fun trying to help customers solve those problems in our technology, and then taking those learnings and applying those to other scenarios. And that's really a big joy of the job. And I've been to 26 unique countries for Tableau since the start. It's been loads of fun spreading our message across the entire globe. I can remember last year about this same time I flew from Seattle to London, London to Dublin for a meeting, and flew from that meeting in Dublin to Dubai. And we did like a big event in Dubai. Then I flew from Dubai down to Cape Town. We were in Cape Town for a couple of days. We flew from Cape Town up to London. I think I was home for 36 hours. Then I flew to Tel Aviv. It was loads of fun. So we get all over, right? And that's just how diverse our customer base is. And we can talk about row-level security. We're going to talk about a couple of very specific scenarios. And the problems expressed in these scenarios aren't unique. The complex row-level organizational hierarchies with healthcare is very complex. But we also have sales solutions and other solutions that are also very complex. And when I whiteboarded out how many ways we could accomplish row-level security in Tableau, I came up with 9 when I was exhausted the entire list. And some of them are a bit creative. And so I want to take a quick survey. I mean, who here is using kind of SQL Server as their enterprise solution? All right, very good, very good. I run it locally. I'm a SQL Server slappy. I was independent for 6 years, and I took SQL Server down many, many paths. And then who is using Oracle as their enterprise solution? Very good. Anybody using the Exadata appliance? All right, got a couple. Very good. And then who is using Teradata here that came today? All right, you're going to be a little bit disappointed. We're not doing much on Teradata. Sorry, but they do have some special, unique things with a very robust metadata layer you can get to with query banding and other methods in Tableau, and that's very well documented. Who here has more than, well, let's just do it this way. Who here has more than 10 million rows in your primary fact tables? All right, keep your hands up if it's greater than 100 million. Greater than a billion? All right, a few billions in here. Anybody greater than 10 billion in your primary fact tables? I've seen, excellent. Oh, I want to spend time with you. So I think the biggest fact table I've seen in the field that Tableau was hooked to was actually 18 billion, and that was it was in Tel Aviv, actually. But their source system has almost 2 trillion records before they condense it down into their data warehouse. So that's rather robust. All right, thank you for letting us do that quick survey. I'll hand it over to Anthony to get into the meat of the presentation.
All right, guys. So why are we here? Obviously, security matters. And despite what the philosophy may be of certain companies about data wanting to be free, there are plenty of folks who would feel very threatened by that idea. And in many cases, rightly so. So management cares about responsibility for the business. Information is an asset. Information can unleash creative potential. It can help you build analytic culture. It can also destroy morale. It can threaten your intellectual property and loosen the focus of the organization. IT's job is to service the business, including the priorities of management as discussed. Analysts are going to leverage the security policies that IT puts in place, and the business users are going to view and consume that information. So when I think about row-level security, I think primarily about user and group-level grants and denials. So you can see some things. You can see some things because I told you so, or you can see some things because you're a member of a group that can see some things. And sometimes there are cases where you might want to explicitly have people not see things. And today we're going to talk about how we do that in Tableau and in the database. So let me propose at the outset that there are a number of objectives for any row-level security implementation. The first one, I sort of struggled for a name. I called it filtering. I now say effective filtering implicitly. Robustness is a characteristic you want. So you want to be able to restrict rows, but that's not all. You're interested in immutability so that someone with Tableau desktop can't just download your report on the server and delete out the security that you just put in it. Wouldn't that be a shame, right? You want, if you're distributing data in Tableau Reader, you're concerned about people getting more data than they're allowed to see. And the Tableau, workbook, packaged workbook allows that. You're interested in performance, so it was very interesting to see those hands go up because most of the people here, raise your hand, are you here because of performance issues with row-level security? Okay, that's actually a smaller number than I thought. Well, we have magic for you. The fourth, you could call it convenience or single sign-on. So you could have all this security, but you need a backpack full of tokens to get to your data, and you're going to be doing it every time. And that, when that happens, people generally turn it off, right? And finally, you're probably interested in some column level stuff, right? So you're interested in making sure that social security numbers aren't shown to the wrong people or credit cards, or sometimes you want entire columns to just disappear from reports. We can't do that, but I empathize with and
to kind of add to that just a little bit. right? We also, in the performance category, we want to make sure the solutions that we're hooking into are also very scalable as the enterprise changes and adds members, adds groups, adds territories, and removes members from groups and territories. We want that, when we make those changes, to have inheritance into our row-level model that we're exposing to our business intelligence tools.
So let's put a concrete example out here of kind of what you want. So at the end of the day, we're interested in reports that are published to the server that change when the usernames change, that can't be, where the security can't be removed by the end user. So let's just sign out. And let's sign in as an end user. Let's call it a department administrator. Oh. How about we drop out of presentation mode here? Duplicate. Go ahead. Thank you. Awesome.
I must be too much of a Windows user when I know all the Windows key shortcuts. You can even hit Control-Shift-N to create a new folder in a directory.
That's awesome. Okay, so the demo set we're looking at is de-identified healthcare data. And in order to make this work, we'll show you the steps we went through to build an organizational hierarchy and certain bridge tables to support the use case. But so in this case, the viz shows departments by month that were successful in administering flu vaccinations. So there's a success ratio that we can toggle, and as we know, if we lower the bar, more people pass. And we can filter based on, say, only the departments that were successful and those that were not. But it's possible that you might not be privy to all of this information, and we could simulate that by logging in as another user. Awesome.
Is that freaking you out?
That's cool. So this person is works in 3 departments or 4 from time to time. So we can only see those. If we drill down to the doctor level, you'd see, and we'll show it later, that she can only see herself, and the other doctors are kind of X'd out. And if we log in as the executive director, so we'll do exector, then that person can see everything. The security is enforced at the data source level, so the users have no direct access to the database. It uses a system login, and all the business rules are in the data source as well, which they don't have edit rights to. So, so they can't undo the security. All right. So if that's the end goal, how do we get there? Let me just do this. All right, so if that's the end goal, how do we do this? So not every use case are you sort of a DBA super user running Tableau. We've made we've launched our company by supporting the less technical user with fewer rights in the system, okay? So let's not overlook that capability, because I would argue, like, let's just have a quick show of hands. How many of your Tableau reports are backed by Excel files provided by business users? Do you have any of them? You have one of them? It's actually way less than I thought. And that shows this is an enterprise crowd. So our goal, in the enterprise, I'm an enterprise salesperson, and presumably yours, is that all data is sanctioned and certified. At the same time, there's a service level understanding that business users are going to get the data they need quickly. So if they do have Excel, then they can send it to you, or you can put it into some kind of trusted source and do so quickly so they're not fighting you and end running. Now, how do I do this user level security? So let's start out with this report here. It accesses all data, and it's got no security on it right now. So I'd start out, I'd log into the server, and then I would go here to create user filter. I'm going to choose department specialty, because that's the dimension I'm going to filter. Okay, and I'm going to create a user filter for, let's say, members of family practice group. So members of the family practice group, I'm then going to grant them access to members of that dimension. So I'm going to say members of the family practice group can see data in the department dimension with the value of family practice. For grins, let's give them gastroenterology as well. Now, when you create a user filter in Tableau, it doesn't by itself do anything. You need to add it to the report. Now, let me use this impersonation feature. So you may know that if you have rights on this to log into the server, you can then change the user. So let's just start with looking for family practice. And now I'm going to see what the family practice person can see. With the report as it is, I can see everything. I'm going to add this user filter, this set. It's got, you see the little man next to the set? That tells you that it's a user filter set.
Yeah, and that filter is going to be a persisted set into the Tableau document, right? So there's some scalability concerns there as we'll move forward. And if you were doing that for grins, you probably should have chose orthodontistry.
Good stuff. So we can see here that the department narrowed from a big long list to family practice, and we can interact with this report freely. Now, what's the problem with using this report as is, publishing it up? The problem is that someone with Tableau Desktop who has download rights on the report could simply download it and get rid of this filter. So they could edit it and just go like that. Okay. So what we need to do is to bake that filter into the data source, publish the data source, and remove rights to download the data source. Okay. So how do we do that? We just open up our data source and we add a filter. We're going to add this user filter one we just created, and we're going to hit OK. Now, once we add that filter to the data source, it works the same way as if it were dropped into the filter panel. Okay? And then we could publish that data source to the server, Let me just edit the authentication. Let's just do it this way.
And much like any other Tableau set as well, you can get to some really complex scenarios where you do combined sets on top of the user filters. So we do a filter at like maybe a patient, and then a filter at also a location, and you can actually combine those sets as user filters and drop those onto these as well. It really helps with some really quick POCs. It's absolutely fantastic, and for those of you with way less complex collections of users and entities, it can be a very useful solution.
So when we publish the data source, we have options. In this case, we're going to embed the password. If we prompt user, it's going to prompt the end user for, when they open the report, for a database credential. Now, that's bad, but it can actually be okay if you, not for this use case, we're trying to keep simple, but we do have a setting in Tableau to allow the system to remember your password. So in a situation where you do want to push security down to the database, you're going to require a user password once, and then when their password expires on the database, they'll be prompted for it again. It's really not as bad as you might think it is from a convenience standpoint. So if I embed the password and then publish up this data source, I can also now very conveniently check this update workbook to use publish data source. I forgot to show you setting the security here. We're going to only give admin rights to edit this data source. The end user will only be able to query it. So I've published this data source, and now it's getting the credential of the logged in data source, which is why the data source disappeared. This is you know, a wee bit strange sometimes when you're debugging. You need to, if you want to impersonate, you have to do it a little bit differently. You have to log in here to the data source. So let me go back to like this user here. Okay, there you go. Do you see that? So this thing down here no longer works on a published data source. All right, that's it. Okay, we're back to the PowerPoint. All right, so that's all cool, but you're in that user security scenario, you're explicitly binding the dimension values to the users and groups. So if the users and groups change, you add more, remove more, you have to go back and edit the security on that data source. But what if my security model is dynamic and it's fed by your transactional model, and when your transactional model changes, you want the security to change. So if I add users to your EMR, or I add users to your HR system or your Active Directory or whatever, that they just inherit the security. Now, you can mitigate that a little bit with group level security because the group membership can be dynamic. But if you want an entirely dynamic system, especially with dynamic user level rights, it's not practical to use Tableau as a data security administration system. You're going to want to implement a dynamic security system. And the two primary tools within Tableau are going to be username and the group name filter.
We had one question there.
Yeah, go ahead.
With the group solution, I noticed you're using live connection though. You know, for some of us that have large data sets, we can't afford live connections. But if you make that an extract, then that data source put it in the data source wouldn't work.
We'll get to that later in the presentation. We'll address that very specifically for you.
It does work on extract, the user filter.
Yeah, the user filters do work on extracts, right? When we extract, they create those dimensional filters. There's some caveats to using extract in a row-level security type scenario with kind of record count explosion.
Yeah,
and
but that's
we'll
actually a
address
pretty
that.
good use case for extracts. If you can use user-level security, you can use extracts, and it's very fast. I don't know if there was a question in there about that.
If you publish security, how does it create extract for every user?
Oh, it doesn't. It creates one extract, and it implements the security at runtime on top of that. Yeah. So it's actually a really good use case. Now, you might not want Tableau alone to implement security. Remember, we said, do we want to use Tableau to administer users and groups? Do we want to use Tableau for the business logic around security? Well, I mean, most of you have other tools in your environment, whether it's Cognos or Business Objects or Microsoft or whatever else, even direct access from Excel and so forth. In order to maintain security consistently across the organization, the ideal would be that it's secured at the data level, so that if I connect to the database with anything, I get the same results based on a login or some kind of a context setting that a person without DBA rights can't do. So early in my career, I used a lot of Oracle VPD, and I still consider it the premier solution for this problem. There are certain I can't say that there are security filters that you can write in VPD which cannot be articulated in the Microsoft RLS function, which just came in 2016. I don't think that's actually true, but it might be. It's incredibly powerful. Oracle has, without a doubt, also the best redaction story. So you can, at the database level, mask fields. And you can trigger that masking based on not only on the login username, but context variables set in the session, initial SQL, and so forth. Microsoft is catching up. We have customers that are very successful with Teradata using query bands. I don't know what the redaction story is on Teradata. Let's talk briefly about modeling the data for this dynamic scenario. So we're going to generalize here because every situation is different. But there may be a philosophy of letting your data be free, in which case you're not going to apply any security. Candidly, Tableau is waiting for its Snowden. Internally, if you work at Tableau, you can see everything in our Salesforce database. Now, you can't see everything in the finance database. That's completely walled off from the sales folks. But we've decided that the costs and are lower than the benefits of giving unfettered access to that data. In some cases, you just want people to see their own data. So it's my, I go log into Workday and I just want to see my profile, my incentive, and so forth. It might be common for you to have group level access to data, so in which case I want to see my departments or data for my entire department or other departments. And then we get into some more nuanced examples that are more common than not. Who has this use case? I want to see the data for myself, but also anyone who works for me. Does that use case come up? Okay. And then things get a little more specific than that, like, for instance, I give you access to your data plus this one person's data or this one customer account data, or several, in which case you have explicit grants modeled that are a little less dynamic, but need to be accommodated in the model. Does anyone have that scenario? Okay. Explicit denials. Does anyone have a scenario where, for whatever reason, for instance, at my law firm, I have conflict between customers and I just can't see the data for this specific account, even though they're in my department? Otherwise, I could see that. A few people here. Okay, great. So, I think I'm going to present information on these use cases, and they're not so common in this room. But I think that by presenting them, hopefully you feel safer and more confident in suggesting that you can solve these problems, and I think that'll allow you to have a richer conversation with business as a result. Because sometimes when the problem is just too hard, we punt. I'll finish with a little story on performance where, we do have a partner that fully replicated the Salesforce security model relationally using row-level security in SQL Server. But the performance was absolutely unusable. So, sometimes when you hit hard constraints like that, you change your requirements. So hopefully we'll broaden the envelope of requirements that you can consider here today. So briefly, you would recognize this schema as a standard star schema where we've got some facts and we have users who have implicitly entitlements and relationships to those facts. And then we have an organizational structure. Obviously, I was no good with my PowerPoint here. Organizational structure defining who works for whom, which I heard was a common use case here. That management relationship. So in this case, our doctors are called providers. They have a provider ID, and the managers have an ID. Well, that's not particularly scalable at runtime. So in our model, we have taken that employee-manager relationship and created a username list table. So in other words, for every employee, we're going to show all of their managers in a list all the way up to the CEO. We're just going to put that in a big text column. We're going to start there. Now in Ralph Kimball world, this is called a hierarchy bridge table. Actually, the next version of it, the pivoted one. Sometimes people talk about that list of things as a bitmap. Sometimes it is a bitmap. Microsoft has a new hierarchical data type. Makes it very easy to work with that type of information. But with traditional methods, especially as your logic becomes more complicated, you really can't deal with a list of usernames or a list of IDs for security. It doesn't work. We want to pivot that out into a table, and we're going to call that an ancestry table. And it could have IDs in it, or for our purposes, we really want to see a username. And then we might have these sort of outlier tables that aren't necessarily connected with explicit grants and denials. In this case, I have a grant and denial department table and one for facts. So when you take a look at this model, understand in your mind that we're going to be filtering on username. And that's either going to, wherever that happens, it could happen in the database using row-level security, or it can happen in Tableau. We are going to need to effectively do a filter, a join, a constraint on that column at runtime. Now there are 3 fields here: username, an ancestor unames list, and an ancestor uname field. They have different meanings on the model. If I filter on the username on the fact table, what I'm saying is, show me all rows associated with this user. If I filter on the exploded ancestry table, I'm effectively saying, give me my records and those of all of my descendants. So if I filter on an ancestor, I'm actually constraining to the descendants. I can't see my upstream, but I can see my downstream. And just to give this a little more color, departments and facilities look like this. The users look something like this. I just numbered them, user 1 through 19,000. And the organizational hierarchy has a provider ID and a manager ID, and that's what we get from the transactional system. That's not usable for us out of the box. So we need to pivot it into this ancestor list thing, call it a bitmap, call it an ancestry list. And I've used the pipe delimiter character here. And then this is the normalized version of that, where we've pivoted out to ancestry tables. And this is what our explicit grants and denials looks like. And we might have a flag for a grant and a G for grant and D for denials. You might model it differently. And then in order to make that usable, we've got to start building some views. And we're going to build those up. We have to deal with this recursive relationship that's going to be slow at runtime. And then we have to apply this filter that says, logically, a user and all their managers are equal to the username. Some databases can do this. With Oracle, I used to use connect by. It's now, with common table functions, possible in SQL Server as well. Other databases have other means. Sometimes you need to use ETL tools instead of doing the transformations in the database. For starters, in a data source like this, you're going to take that user-manager hierarchy and you're going to join them with the appropriate user table so you get the user names. That makes it usable and you get these additional, that username field that we can key to based on the Tableau login.
And just to add something there, with Tableau, we can pass in that logged in username, the system name, and we also have a full name operator as well. So if you needed to have the names be different than their actual system name from Active Directory, because your database was around before that, you can actually use that full name character to kind of spoof that.
Now, how do we generate that list of ancestors? So in this case, in SQL Server, we're going to use a common table function. And the first section talks about the seed to the function, like that first row, and then we recurse from that. So we're going to start with the top level manager, the executive director, the zeros, the nulls, because you don't report to anyone. And then you're going to then recurse and pass that back to itself. The syntax is very specific. It's pretty flexible. I was surprised by how fast it runs. Once we get that all flattened out, we're going to use that, and we're going to use that for the extract example. We're also going to use that. We're going to then split it and explode it using this very nice string split function in SQL Server. And we're going to split it out and get that, that normalized list of provider to ancestor. Any questions so far? Okay, cool. All right. So a simple filter would be joining the fact to that exploded ancestry table. And we can do a straight column equals username filter on that. If we're talking about the ancestor list, we're going to use a string function. String data structures pretty difficult, long strings to compress, especially in a column store, and you'd recognize column store in the extract engine. That being said, joins are very expensive, even index joins. So, although the purist will mock the list, the long list of names, it might actually perform faster than joining on the exploded ancestry table. Now, the actual filter can be applied in many places in Tableau. We showed you the regular filter shelf. We showed you the data source filter. You wouldn't want to apply it to an extract filter because then it would eliminate it from the working set. It can also be done in the database using VPT or RLS. That exploded data structure does not scale in extracts today because extracts today require during generation a big flat single table. So let's just say, for argument's sake, I have 10 rows in my fact table, but I have an ancestor table with 1,000 rows. And let's just say, for argument's sake, everyone can see every row, but it's explicitly in the database. So it's going to be the full Cartesian product 10 times 1,000 in the number of rows that are in the extract during generation stage. So you're going to have 10,000 records with all the data duplicated for every single security record. And then after it creates its temp files and starts building its extract, then it's going to compress it down back to something actually pretty close to the original. So it's not the size of the final extract, it's the size of the interim steps. So hopefully you guys were paying attention when they introduced Hyper. And Hyper is a much more sophisticated device which will support multiple tables and it support incremental updates. And so some of this presentation, some of the sort of strategies for dealing with performance situations will change dramatically in a hyper world, and you'll be able to use extracts for these kinds of problems much more flexibly.
Yeah, completely agree with that. I really can't wait for that to be in our toolbox, to be quite honest.
So what happens when we introduce explicit grants and denials on top of that is kind of a mind blower, but we can do that using unions and exceptions in SQL. So we end up with a custom SQL world. Now, and when you combine SQL statements using unions and exceptions, or minus in some tools, intersections, all the columns need to line up. And you have to assume that the underlying filter, if I filter on username, it's going to be passed to all of the expressions in that complex statement. As we showed before, sometimes we're filtering on the username on the fact. For instance, maybe we're denying rights to that fact to that user, but our grants are off of the ancestry table, so we're going to have to alias the names so that they're the same. So if we're actually filtering on the ancestry table and we're unioning it to a filter on the dimension table, we're going to call everything username. And the data source is going to resolve the joins differently. It's going to give me grants to everything I can see and my employees can see, and it's going to give me also grants to the explicit things that I've been called out to see. So at the end of the day, we end up with something that is very simple and usable for the user. I put envy in here because materializing these views is important. Now, you can't materialize the top view because the top view with the grants and exceptions has to remain flexible. You can't just explode all that data and save it. But the underlying pieces you can. You would never want to do that recursion that I showed you at runtime. Now, I've done it, and we're going to look at the performance of it, but it's 100 times slower than if you just save the data. It could be thousands of times slower. All right? And you'll notice that there is no ancestry username field here. It's just username because we've aliased it in the views. And this is like the actual SQL statement that I used in the demo. And you know, the first time you do it, it's going to be create view, not alter view. But you've got a union of several grants, and then you're removing rows using denials. Any questions so far? Okay. Before we jump into seeing the various scenarios live, let's just talk briefly about Oracle VPD. So this is a very old feature, and I think you're seeing it today from Microsoft because it's falling out of patent protection. And that means that we'll see it from all the databases. It's just conjecture. But when something appears 17 years after a competitor, you kind of get that feeling. So Tableau still has some protection then, right? It's kind of auto magic. Let me just, I don't want to embarrass anyone, but raise your hand if you don't know what Oracle VPD is or haven't used it, just to give an idea. Okay. So that's cool that this would be a new kind of idea for a lot of people in this room. Let's just take a look at it logically. So imagine, if you will, that everything in the query context, the initial SQL, the username, the machine you're running on, anything you want to put in at runtime is available to you in this environment. And then you write some PL SQL, which is some custom code, that can take this information and, based on whatever logic you want, add stuff to the where clause. So it generates a conditional clause. So if I'm director of IT, I can see IT, but only during the hours of 8 in the morning till 5, but I don't want Johnny, who's a temp, to see it. Whatever you want, you can create. Okay, so you build that in isolation of the tables. And then you have this thing called a binding that binds that rule to the table. And it actually works the same way in Microsoft, although the syntax is quite different. Now, at the end of the day, you're querying the original table, but this stuff, this magic wrapper gets applied for you, okay? So you might query from your tool, select from table X where product equals Y, but the query that actually gets executed is select from table X where product equals Y and region equals East, and whatever you like. So the first time I saw this and played with it, I was kind of blown away, and it's very impressive. Now, SQL Server released something similar in just this year, and their policy syntax is different. The limitations are really significant in SQL Server. I wasn't able to bind it to a view or to an index view, a column store index view. It didn't work with the in-memory tables. Now maybe I don't sit in a DBA role, so there may be nuances that I didn't appreciate. But the limitations gave me pause. The syntax for Microsoft looks something like this. The first statement is the rule, and that username expression here is actually passed in a function, so that could be any column in the database. This is the binding statement here, where we're basically saying we're going to bind this function to, remember we had two versions of the username column. We're going to bind it to the ancestor username, and in the other case, we're going to bind it to the actual username. So we can take the same business logic and apply it to many tables. Now notice, this is not the database username here. This session context refers to a runtime variable that actually we define. So we could have called that, foo or whatever we wanted to. It doesn't matter, as long as we provide that at runtime. Now, Tableau supports the ability to do that using initial SQL for the major data sources. It's actually for all the ODBC data sources as of 10.1. Right, David?
Pretty darn close, yeah.
Yeah. So we can now do this runtime magic for all the data sources. And as you know, we can get that username in
we can get workbook names, session details, workbook names, all those kind of fun variables to really address some complex use cases.
Okay. Extracts. So there was a bunch of nodding when we were talking about the extract use cases. I think you guys appreciate, and you probably run into the explosion problem. If, as you were building your extract, we did not join the tables during the generation or runtime of the extract, and we left them separate and resolved them at runtime as we do with a regular database, you would not have this problem. Today, we don't do that. We join, we flatten, which means we copy every row in your fact table for every row in your security table. We're duplicating all that data, we're writing it to temp files, and then we're sorting and compressing it. And that's the problem.
Yeah, and even if you get clever and create an extract of your security table and an extract of your fact table, and then join them together in Tableau's new data integration feature, you will be a little bit disappointed because of the way Tableau uses that data integration feature. It actually pushes members from the left column, from the left side into the right side, and does the join within the right side. So we actually don't handle it in the Tableau layer. We push it down to the database to do the joining. And when I have a large list of unique members, like that security and ancestry table, it would actually, the performance kind of goes. But that feature will get better.
Yeah. So in the future, we're looking at cross-extract join, multi-table extracts, incremental updates, and so forth.
Yeah, Hyper will be the answer for being able to take two different extracts and join them together into a relational engine. There's a talk at 12:15. It's like Hyper goes boom or boom goes the database. I'll be going to that one myself.
Okay, so let's take a look at some examples here. So this is vaccine success, no security applied. This is going to be looking at the data across medical centers, departments, months, and so forth. I used this view to identify the user that I was going to focus on here, and that user is logged in here. This is a doctor named Mercado. So if we implement the simply the join on the fact table, we just get her records. So this is Mercado Peregrino. These are the departments she works on. That's her view of the world. And that is very simply, if we look at the data source, the fact table raw with a data source filter. In this case, we're saying the username, and we're setting a condition, username equals username. I've also added something which says, if is a member of the see all group. This is not dynamic at runtime. You have to specify the group, but let's just say you wanted to override if I'm a super user and I don't want to take the time to explicitly code that person in here. I could have that field. So that's the simplest use case, and this is legit if your rules are simple, and you can publish this as is, and it's useful. This is the user level security we looked at. Here's a case where I'm using the manager table to, let's just take a peek at this one. So I was using the manager table to build the ancestry table. I'm joining the ancestry table to the user table. I could also join it to the fact table on the user. Actually, the fact table has an ID, a username ID, so that's why I go to the user table. And then my filter is not applied to the user table itself, it's applied to the ancestry table, but it's a single equijoin, right? So I can see all the information that Mercado can see and anyone who works for her. Let's choose somebody who does have, let's choose a department manager, a director of family practice. And this director doesn't actually see patients. So the director, so if I go to my visit records, which we'll do after this finishes executing, you'll see there's actually no data if you just do that join.
And usually as I'm modeling these scenarios, sometimes my biggest goal, and probably a good rule of thumb in these scenarios, is you should list your new username once and only once and use appropriate many-to-many join handles to join back to the fact tables. I have seen in the field some folks doing some odd stuff by listing a fact ID and a username in a table, like in its entirety, and I thought that was kind of weird. You know, it was a company down in Australia using Greenplum, and they're like, it's fast column store, it'll just work. I mean, it worked, but it didn't scale very well. Yes, sir.
So if you need your security to be dynamic and you need extracts, you mentioned trying to try the contains filter on after you extract it up to have multiple usernames that have access to a single row, because the problem is obviously our extract is becoming huge. Start teaching it.
Yeah.
So let's take a look at that. So yeah, if you were following closely here, the extract loaded in the blink of an eye. We'll look at the numbers in a minute. And if we take a look at the condition here, it's slightly different. So we're using contains, and on that list, then we have a pipe character and the username and an end pipe. So it's important to have the end pipe, because what if you had a user called, J Smith and another one called J Smithy? Well, Smith will match Smithy unless you delimit the end as well. Okay, so it looks the same, but instead of this being a one-to-many relationship, one user has many ancestors, one user only has one ancestor list expression. So that's effectively a one-to-one outrigger table. And that's super, super fast. Okay, everyone catch that? I won't click back on this one. This is what the explicit department looks like, department grants. So for urgent care, there are 76 users who have grants to it and 15 users that have denials on it. In terms of FACT permissions, you have this user has 55 FACT grants and 157 denials. If we combine all this together in the magic, we're putting it all together. There's a bit of caching that's happened as we use SQL Server, so that 1 minute query is really uncharacteristic. As you use these databases, they kind of get smarter. The performance is not that bad, even though this was 5,000 marks. If we go back to the that individual practitioner, you'll see that the performance is almost instant. So really, depending on the use case, even though the rules may be complex, if the working set can be reduced to a small number, the performance is pretty good. Just for sake of time, I'm not going to click on the V because that does that runtime recursion at runtime, and we'll look at the performance of that. But the row-level security implementation of it is likewise lickety-split. And now let's take a look at the performance summary of these things. Thank you, David, for the magic of putting this one together.
No, just thank you, Tableau, for having the data interpreter, because we had a massive crosstab spit out in Excel. So the data interpreter actually took the merged zones from the Excel and interpreted it correctly. And then the union feature of those sheets actually, when I dragged and dropped all the sheets in, it actually ran the data interpreter the same way on all those sheets with the different schemas. And it was, I was like super happy because I was getting ready to do it all in Excel. I was like starting that path. I'm like, wait, let me try it in Tableau. And I was like super happy. And then I went out with the guy who developed that feature, Roger Howe, and gave him a giant high five. He was super happy.
Cool. So here's that view, and we're seeing, depending on how many records you can see, in this case, 19,000 for the executive director. He was waiting 220 seconds for that if I'm calculating it at runtime. If I take out the views and I only look at the materialized structures, implementing in the database using the row-level security turns out to be the slowest. So SQL Server in this case was quite a bit slower than we were at providing the username directly. This was a fairly simple data structure. I can't. This one and this one don't really make sense. I'm going to guess that maybe caching. There was some caching thing going on here. I tried to clear the cache, but the results here. We like to see 2-second response time. The results here aren't terrific. If you're the executive director, you're really going to want to be able to do that or can see all using the group level security to punt the filter. But if we, for your bread and butter use case where the end user doesn't have access to the whole database, they're dealing with a smaller working set of information they can actually see. So this departmental leader that can see the data for 4,000 employees, you end up getting to reasonable numbers. This is 30 seconds, which is awful, but you won't get fired for it. And then you very quickly get into the 2 seconds and so forth. Now, if we change the scale, you can see just how much faster the extracts are. So if we take the scale down to like 1 second, you'll actually be able to see the extracts. And so the executing query in the extract use case is so fast it doesn't even show up. You're spending most of your time computing the layout. And that's magical here.
So what about like pre-caching separate views for your executive director use cases?
Absolutely. This chart is saying it's worth optimizing the data structures and creating separate tables without all these constraints and joins for those super users.
Yeah, and I've definitely advised some clients on those executives we have a job that runs every 15 minutes, just calls up the Tableau view. So when that executive director logs in, he just hits the cache from Tableau server, right? There's a easy button that'll buy you some runway until you can materialize it.
So, this stuff does break down. It always breaks down at some point. The complexity will grow, the number of rows will grow, and you will hit the wall. What we found in the field is that databases that are in memory perform considerably faster. Just the physics of it are such that DRAM is about 20 times faster than SD disk, solid state disk. So just because you're running in an in-memory disk doesn't mean you'll get all the performance. When you use a product like Exasol, we've seen performance even 10 times faster than Redshift, which is kind of a hybrid model. Perhaps 100 or 1,000 times faster than SQL Server and Oracle. So do consider changing the physics of it by getting a faster database. Do not consider that every problem that you throw at it will be solvable in a reasonable amount of time. Size matters, complexity matters, joins matter. So if we were to just summarize the overall things we've talked about today, the pros of user filters is there's no script in SQL code. The cons is it's static. As the data changes, the rules don't change. Memberships can change. Let me. I'm having trouble seeing all that in the PowerPoint. So if you let me just reduce the size here a little bit. Okay, sorry. The young kids are really smart about this stuff. In database is consistent across all tools. It's not supported by some databases, and it does require some DBA work and skills. The user filters from Tableau and the data source layer, they don't support all logic. You're not going to be able to reduce every rule to a username column equals username expression. Sometimes you're really going to need to apply that in a more sophisticated way in the rules at runtime, which a VPD can give you or a row-level security function can give you. Likewise, with group filters, the isMemberOfGroup, very powerful, very fast, but there are challenges. I present this grid as a high-level simplification, and I provided alternate coloring schemes because sometimes a strategy might be good enough for you. So a user filter in the data source might be good enough for you. Now, overall, it's not as flexible as some of the in-database security, but it might be good enough for you. And the in-database security, you might not have access. It might not be right for you. I want to tell you not to look at blending as a solution to this problem, because blends are defined in the workbook. They can't be made part of the data source. With the new federated query in 10, you do have different options. Blending should not be something you should consider, even though as a desktop user it might actually work for your use case. And as far as redaction goes, you're not going to have those options with user filters, although you can write formulas to do it. I'm assuming if you're using user filters, you're not writing formulas. So those are the final thoughts. There are some miscellaneous things, but let me just, I know we're kind of at the end of time. Let's open up to some remaining questions and be very open-ended about this if you'd like to stick around. It's being, you mean as part of the extract, if you're just creating a big text blog field? I don't think there's a limit.
Just keep chopping it up.
Yeah. Thank you everyone for coming, you guys out there. Really appreciate it. Give us good grades on your survey.